So we want to look at the graph for our logarithm. And let's look at log base 2 of x. If you think back to the key points that we just described and wrote out, we're going to be looking at having 1, 0 here for our anchor point. And then, basically, if you do the key points for the exponential but backwards, you're going to be okay. So instead of doing negative 1, 0, 1 for the x, do negative 1, 0, 1 for the y, and work backwards. So if your base is 2, if I had done my exponential, and I'd done 2 to the negative first, what do I get?
1/2.
I get 1/2. If I did 2 to the first, what do I get?
2.
And that's what the key points would have been for our exponential. But we're looking at them swapped around because we're talking about the inverse. So if we plot these guys, again, start with your key point, which is 1, 0 right here. We also talked about the fact that we have a vertical asymptote of x equals 0. So let's go ahead and put this here. That way we know that we cannot cross this. Since this is the inverse of the exponential, you're going to have something that looks like that exponential graph, is kind of turned on its side. So your exponential would have done this, would have blown up like that. This guy's going to be starting down here and curving out like that. It's like an exponential that's riding along the y-axis. So 1/2 is negative 1. 2 is going to get you 1. Instead of measuring your distance from the x-axis, you want to measure your distance from the y-axis. Notice that the distance here is 1, right? What's that distance? 2. Since my base is 2, what do you think the next distance is going to be when I go up a step?
4.
It's going to be 4 units out, and then what?
It's going to be 8 units.
And then 8 units, and then 16 units out, right? So if you come backwards here, that's 8, 4, 2, 1. You're dividing by 2 each time. 1/2, 1/4, 1/8. You're getting closer and closer to that y-axis, but are you able to touch it?
No.
No, because that is going to be your vertical asymptote. In addition to the fact that when we talk about the key information for your logarithm, we said that your domain was going to be greater than 0. And then throwing in the range is negative infinity to infinity. So here's what your logarithm looks like. What do you guys think?
Do you have a name for it? Like a genie?
No, I don't. Sorry, I feel like I should have it.
It looks like a geyser that's shooting out
Yeah. Maybe.
a hole in the ground or something.
For some reason, I'm thinking about those little devices that you have in the mall where you can drop a quarter in it and it just kind of spins around and around and around to the very end. Those are so much fun. My parents are like, stop dropping the money in there.
You seen the rabbit hole from Alice in Wonderland? You go in there.
Did you know that Lewis Carroll, who wrote Alice in Wonderland, was a mathematician?
Really?
Isn't that amazing, crazy balls?
No idea.
At least I think so. Of course, if that's wrong, I should probably edit that out of the video because of all the editing that I do. No, I don't edit anything. If you look at the exponential, the exponential would have been up 1, 2, 4, and 8. And then here's the 1/2. So your exponential would have looked like this with a base of 2. Okay, so this is 2 to the x. And here this is log base 2 of x. And if you remember from the stuff that we did before, if you were to draw your identity function through this, we see how a function and its inverse should be mirrored across your identity function. You guys see that? So over here, when I have the ordered pair 8, 3, that matches up with the original ordered pair of 3, 8. All right, so let's do another one of these where we have to do some shifting. And I want you to see that it's really not that bad. All of the graphing techniques that I showed you before are still going to be true here. The key thing, though, is remembering 1, 0. That's your key point. And you see here that this is a distance of 1, 2, 4, 8. Are you with me on that? Because my base is 2. And I told you that most of the graphs that we do, I like to keep a base of 2 because you can get a lot of information on your graph that way. So let's shift that logarithm. And let's do log base 2 of x plus 3 plus 2. I want you to talk to me about where this guy has been shifted. Because this is inside the function, that's a horizontal shift, opposite of what we see, so that's to the left 3. This is outside the function. You do exactly what you see for a vertical shift, and that means up 2. What I want you to do first is the same stuff that we did for graphing those exponentials. Graph your asymptote first. So I had a vertical asymptote that was at x equals 0. I'm shifting that to the left 3, so that means I have a new vertical asymptote of x equals negative 3. So let me come over here and sketch my vertical asymptote, just to give me some boundaries here. I'm going up 2, and so just like the exponential graphs, I'm going to go from here up 2, and this is going to be my new origin right there. From that new origin, in quotes, where's my anchor point? Where's my base point for all these logarithms?
1, 2.
It's 1, 0, so I'm going to start at 1, 0 right there. Again, that's 1, 0 relative to this intersection. Okay? My base is 2, which means every step I go up, what am I going to do for my distance from that vertical asymptote?
You're going times 2.
I'm going to multiply it times 2 as I go up. So this is a distance of 1. From here, how far out do I go? I go over 2 units. 1 times 2 is 2. Go up another notch. How far out do I go? 4. Go up another unit. How far out do I go?
8.
If I went out another unit, how far out would I go? 16 be somewhere maybe out here. Come back though. This would be a distance of 16. This is 8, 4, 2, and 1. So you see, you're dividing by 2 as you go down each step. Keep dividing by 2. What do you have? 1/2, 1/4, 1/8, and so on. And so we connect the dots, having a shape that is incredibly similar to our exponential, except it's just turned on its side. Yes? Question?
To graph a logarithm with the a being a number different than 2.
Okay, so if the base were something not 2, suppose the base were 3, okay? You would still have this point 1, 0. But if the base were 3, you'd go out 3, because 1 times 3 is 3. Then the next step, you'd be out 9, and then you'd be out 27. The same pattern that we would have had for an exponential, just a different orientation, right? And so some of the questions you might see in your homework will say, oh, graph this guy that's log base 7 or base 10, which means if it were base 10, you'd go from being out 1 here to being out 10 units, then 100 units. And I don't like that because you don't get enough points. Here, you get what, 1, 2, 3, 4, you count the half, 5, pretty nice, easy points to plot. If the base is anything different than that, like a 3, 5, 10, you only get 2 points, maybe 3. And so it's really hard to get a good, accurate picture of that.
But the base for all the anchor points, the anchor point for all the bases is going to be 1, 0.
Yeah. Just like we saw for the exponential was 0, 1. This guy's going to be 1, 0. So you already know this guy's going to be here, regardless of what the base is. And then you follow that base to go 2, 4, 8, and so on. If I had a negative in front of this, hold on. If I had a negative in front of this, it would take this whole picture right here and flip it upside down, right? So instead of going 2, 4, 8 going up, you'd go 2, 4, 8 going down. Yes, Tom, you had a question?
Well, I was just saying, the next thing you'd ask us is the domain and range changed, right? Because we shifted.
Yeah, while we're here, let's do that. What's my domain?
Your domain is -3 to infinity.
And what's my range? Right. For logarithms, the range is going to be all real numbers. Now, for this domain, just a little side note here. The way that you can find this algebraically, so you're not having to depend on a picture, this domain comes from taking the x plus 3, and you set this as an inequality to be greater than 0. The input value for log has to be positive. And as you solve this inequality, you find that x must be greater than -3, which corresponds to the -3 to infinity. You don't get to equal -3. Okay? Because you can't do log of 0. Because think about what that would look like. If I ask you, what is log base 2 of 0? You've got to be thinking about this. 2 to what power equals 0?
It's 2 to the 0 is just 1.
Right, so you might think 0, but 2 to the 0, like you're saying, is 1. What if I make this a negative number? It doesn't become 0. It becomes smaller and smaller and smaller, approaching what value? Approaching 0, but never equaling 0. So this guy,
Logically, like, how can nothing get exponentially bigger? Because, there's no value to add exponentially.
well, I don't think that's the question, like how can nothing get exponentially bigger? That would be saying you have a base of 0.
Oh, yeah.
But you're raising 2 to a power to get 0. Even if you don't have any factors of 2, there's still a 1 that's kind of left over, right? And all you can do is get smaller and smaller, and you can approach at 0, but it's not going to equal 0. So watch out for that if I were to give you that as a question on a test. Hint, hint, wink, wink.